Welcome to another video of Vidhai. In this video, I'll be discussing about the chapter Light and I am a volunteer from the Exams Possible team of Vidhai. In this video, this is the part 2 of the Light where I will be discussing about the images being formed in front of the mirror, that is in front of the concave mirror and in front of the convex mirror. This is an important topic as it is also important for your school exams. So it is very much recommended that you focus in this video. Without further ado, let's move on to the different images formed in front of the mirrors. Now it's time to learn about the different images formed by different mirrors. This is a very important topic and can't be just shown in the slide and taught to you. So I decided to draw it in front of the video. So let's go ahead and draw the types of images formed of the mirrors. First, you're going to see an image formed by the plane mirrors. So the first point is going to be of plane mirrors. Now you have a plane mirror like this. Right. So a person is standing across the mirror. He is standing about a meter of 5 meters. Now guess how the image will be formed on the other side of the mirror. It will be also in a distance of 5 meters. The person will be standing there. Now the question for you is this image, this is the object, this is the image. You see the mirror side, non-mirror side. Now the question for you guys is whether this image is an enlarged image, inverted mirror image or a real image. So now let's write in the properties of the image. The property of this image is it's not enlarged and it's not diminished. The size of this is not changed. So neither enlarged or diminished. Which moves us to the next point of whether this image is erect or inverted. When you stand in front of the mirror, you won't be standing upside down inside the mirror. You will be standing at the same manner that you're standing outside the mirror, which means it's erect. It's erect. Now we have discussed whether the size has not changed. We have discussed that this is a erect image, but is it a real or an imaginary? Is it real or virtual? If you remember the example that I gave you for the virtual, it's a television where people are moving inside the screen. You know this image does not exist in the other side. It's non-existent, but you exist, but this image actually won't exist in real life. It's not like every other object you see in your everyday life. It's behind the screen, it's behind the mirror, which means this is a virtual image. Just like the example of the television, if the image is behind the mirror, then it's a virtual. Right. Now for the plane mirrors, it's done. Now let's move on to the next set of mirrors, that is concave and convex mirror. So number 2 is concave mirror. Before moving on to concave and convex mirror, I will discuss you 3 set of rules. Rule number 1. If you have a concave mirror, you have a principal axis. This is the pole, this is the focus, this is the center. If you have a light ray coming parallel to the principal axis, notice the incoming this Such a light ray is called incident ray. If the incoming light ray is parallel to the principal axis, it will always reflect through the focus of the mirror. Now I can draw many light rays which are parallel to the principal axis, and they all end up to the focus of the mirror. That's the reason why it's called the focus of the mirror. Now let me draw another parallel light ray, and from here it will go back to the focus. This is rule number 1. Parallel rays will always meet at the focus. Rule number 2. You have a concave mirror. Again, the principal axis, the center, and the focus. With this, the rule number 2 states that no matter whatever ray that passes to the center of the curvature, it will always come back to the center of curvature. So let me explain. So I draw a light ray which is going through the center of curvature. It reflects at the mirror. It's going like this. It's going from here to here. Guess what will happen next? It will redirect its path and go back the same path it came again. So when the light ray comes like this, it will go back in the same manner. It won't change its path. It will be just as it is, which means it goes like this and comes like this. These two arrowhead symbol means that the light is being reflected on its own. So this is rule number 2. Now the rule number 3 is a bit tricky one, but it's easily understandable when you get a gist of it. So we have the mirror, the principal axis, now we have the pole, you have the focus, and you have the center of curvature. Now whatever light ray that comes to the pole of the mirror will be reflected in the same angle away from the pole. Now this angle is some angle of theta. This other angle is also going to be theta. Now this, you will again see this in the laws of reflection, but as of now, this is one of the laws that you have to remember until the next topic. Whatever light ray that comes towards the pole will reflect away from the pole at the same angle. So let me draw this a bit more clear. So you have that, you get that light ray and you get that light ray. So it shows like this. This is theta. This will also be theta. By the way, theta is the angle. You know those triangles you will be showing. This is an angle. That small thing is called an angle. So you have rule number 1, which whatever light ray that comes parallel to the axis will be reflected towards the focus. And rule 2 is whatever light ray that goes through the center of this curvature will reflect back on its own and go through the center of the curvature again. Rule number 3 states that the light ray which is going towards the pole will reflect away from the pole at the same angle. With these 3 rules in mind, we are going to draw diagrams of images which are going to possibly be formed in a concave mirror. Now time to draw the types of images that is going to be formed in the concave mirror. Now let's say the object is very far away from the mirror. Now we have the mirror. You have your pole, your focus, and your center of curvature. Now notice the object is very far away from the mirror, which means so far away. This is going to be our object, right? It's so far away that the distance of this is at infinity. such as objects like sun, which is so far away from the earth that could be considered to be of infinity when compared to the mirror. Alright, now let's do this, shall we? When the object is at infinity, all the light rays that from the object to the mirror will be always parallel, will always come in parallel. So let us extend this light ray, and this meets that, and this meets this. Right, now by rule number 1, you know that all parallel light rays that are parallel to the axis of the mirror will always end at the focus. So it ends at the focus. So the image will be formed at the focus. So the image will be formed at focus. And what will the image be as? These are two light rays that are not being formed behind the mirror but in front of the mirror. Whenever the object is being formed in front of the mirror, it's called a real image. Now, this object, you may not see it, but it will be an inverted object. I'll explain to you later for the upcoming examples that we see. And this object is bigger enough than of this point object. It's so small at the focus when you compare to this, so it's diminished. Now you got, now this is for the object which is very far away from the mirror. Now let's go to the next example, that is the object is beyond C. What do I mean of this? Now let us construct our mirror. Alright, so this is the axis, this is the pole, this is the focus, this is the C. Now what I'm gonna do is draw an object which is just beyond C. Right, by the way, all the distance of the objects and images will be measured from the pole. That is, when you measure from the pole, this distance of the object is more than the distance from the C, right? So this object is kept not too far away but quite far away from the mirror, such a manner that it's going beyond C. Now let's see how the object is going to be formed. Now here we are going to implement all 3 rules, or you can, if you even implement 2 rules, it's more than sufficient. But for this example alone, I'll be using all the 3 rules, and from the next example onwards, I'll be only 2 rules, any 2 rules. So let's implement the first rule, shall we? So the first rule is drawing a light ray which is parallel to the axis, and that light ray will be reflected back to the focus and will keep on continuing. Now this is the rule number 1. Now the rule number 2 says that when the light ray passes from the object to the center of curvature, it reflects back on its own, so there's no change in path. For the third rule, what I'm going to do is draw to the pole of the mirror, and it will reflect back in the same angle. So you can see all these 3 light rays are meeting at one point. So in the end, how the image is going to appear is like this. The image is going to appear like this. You can see the head is being downwards because all the light rays are coming from that point, and when you draw the light rays from the tail, everything will meet at the pole and again reflect back as a plane mirror. So the tail is on the axis, the head is inverted. Then clearly see that this is the object and this is the image. You see that the object is greater than the image, that is bigger in size, and the image is smaller in size, which means First, we'll determine the properties of the image, which is it's real, meaning these light rays meet at one definite point and it's in front of the mirror, so which means it's real. And from this we can already know that it's inverted, it's straight up and it's downwards here, so inverted, and it's diminished. Now the position of this image is, here lies C and here lies P and here lies P. This is F, sorry, not P. You can see the image is between the center of the curvature and the focus, which means the image at between C and F. So whenever the object is beyond C, the image will be in between of the center of the curvature and the focus, no matter where it is. Now let's go on to the third case. It's at C, meaning the object is going to be on C. So this is the pole, this is the focus, and this is the center of curvature. So how is the object I'm going to place it? Like this. Now I'm going to draw a light ray parallel to the axis, and so the light ray will pass through the focus, correct? Now I'm going to do a reverse algorithm for the rule 1. I'm going to draw a light ray through the focus rather. And do you guys have idea of how the light ray is going to be reflected? The light ray is going to be reflected parallelly to the axis. If you take a light ray like this and it reflects back there, the converse is also true. So when this light ray goes from here to here, when I do the same light ray from here to here, it goes in the same manner because this is a mirror. Now I'm going to draw the image. The image is being formed at C itself. Now let me draw the image and the object. So this is the object, this is the image. You can see the image is on C itself. That means it not change its position, it's just that. Now we already know that it's real and we know it's an inverted, and we know that this image, whether it's going to be diminished or enlarged, it's neither. It's going to be of the same size, because this image and this image, the size did not change, which means the only thing that I've changed is the inverted part. This object is real, image is real, it's of same size and it's only inverted. This property of not changing the real and the same size of the object but only changing its inverted is used in many applications of mirrors. Now with that being said, let's move on to the next part, which is the object being between F and C. We will have to draw the concave mirror. After drawing the concave mirror, we'll mark the point P, we'll mark the point F, and we'll mark the point C. Now let us draw an object between F and C. So I'm going to draw an object like here and apply the first two rules of the thing, or even the last two rules, not a problem. So draw a light ray parallel to the axis, and that will pass through the focus, and
I'm going to draw a light ray through the pole and then it reflects back out. You can see it's been intersected here. Now if I'm gonna draw an image like this, you will notice a similarity between this and this. That is, the image being beyond C. So this is the image really large and this is going to be object. Now you can see from the past example, we know it's real, we know it's inverted, but it's enlarged, it's big now. You notice the difference between this case and this case. All the two of the properties is same, but here it is enlarged, here it's diminished. Here the object is beyond C, here the image is beyond C. Here the image is between C and F, here the object is between C and F. You can see this inverse property everywhere in mirrors. And then we can actually conclude that image is beyond C. With that being said, let's move on to the next. Point number 5. At F. Now at F, the object will be at F, but the image will be interesting. So let us draw a mirror. And mark the point P, mark the point F, mark the point C. At F means the object is on F, it's standing on F. Now let us draw a line, light ray parallel, and then draw the light ray going through F. Now let us draw the light ray go through P, and then let us draw a light ray going away from P at equal angles. Notice that these two light rays will never meet, which is safe to assume that the image is at infinity. Which means it never meets, it's going to infinity. And we can safely assume that it's real, right? And then we can say it's inverted and it's enlarged. Now you notice this case and this case to be similar because you have real inverted, real and inverted, but here it's diminished, here it's enlarged. Same to these two cases are converse of each other. You have the object at infinity, here you have the image at infinity, here you have the image at F, here you have the object as F. It's same manner of these two, now it's of this two. Let's move on to the next and the final point for this. It's between F and C. Now let us draw a mirror. Now the object is here. Let us do the rules again. Now the rules that I've used here is rule number 1 and rule number 3. But notice the image on this side is going away from each other. It's going away from each other. It's not going to meet here. The light rays on this side is not going to meet here, but it's apparently going and meeting this point. See those dotted lines? It's meaning like imaginary. So apparently imaginary, it's going behind the mirror, and this point, this image, this dotted line is of course a virtual image. The only and the one case that a virtual image will be formed in a concave mirror is this case between F and C. It's quite an important case to remember because all the other cases have similar real images, but this only has an virtual image. We also know that the size of this is enlarged. And it's erect. Right. We know it's virtual, we know it's erect, we know it's enlarged. But where is the position of the image? We have seen image at infinity, we have seen image between C and F, but here image, we will say behind the mirror. Now, there's no proper position name for this, we just say it's behind the mirror. So note the point that when the image is in front of the mirror, it's a real image, and when the image is outside the mirror, behind the mirror, it's a virtual image. With that being said, let's move on to the images formed by the convex mirror. Alright, for the convex mirror, we are going to draw the convex mirror first. So draw the convex mirror. Axis, this is the pole. Now the focus in this mirror will be behind the mirror because look at the curving, though this side is the mirror side, in the sphere, the curving path that I've taken is on this side. Like I've taken the curving on this side, which means the C is on the other side of the mirror. So the C will be on the other side of the mirror and the focus will be the same side of the center of curvature. Now let's have a mirror. Let's have an object in front of the mirror. Now let us do the parallel rule 1 of concave, but here instead of converging, it will diverge, it will reflect in an outward manner, and that outward manner will be when in the last case you have seen I have drawn some dotted lines, which means it's imaginary. When you extend the dotted lines, it will meet at F. So it goes like this and goes up like this. You can see the shape and why it's exactly going outwards because of its bulged out, it's going outwards, and for the concave, since it's bulged in, it's going inwards. You get the idea, right? So it meets at the F. Now let's do another one of rule 3. Rule 3 will be the same for everything because it's the pole, and pole of a sphere won't change. Now I'm going to extend this as well. I'm going to extend this light ray that is coming from like this. Now you can see a really tiny image being formed here. We know this image is being formed behind the mirror, so the first property that we are going to write is virtual, and then we can see the object is like this, and the image is going to be in a dotted form, a real small image. So it's going to be diminished. And next, the final thing is whether it's erect or not, and we can clearly see these two images are being erect. Now we form the three properties of the image. Now what is the position of the image, you ask? It will be behind the mirror. The image will be behind the mirror. Now let us take a special case for the convex mirror that varies from this result but would be similar but does vary. And by the way, this is the only case when the image is not at infinity, and when the image is at infinity indeed, which means draw the mirror, mark the pole, the focus and the center of curvature, and since the object is so far away at infinity, we are going to draw parallel light rays. And guess what? It will converge outward, which means these light rays which are going parallel to the axis will converge outward to the light rays which come parallel to the axis will converge outward from the mirror and apparently meet at the focus. We know that this image is virtual because it's behind the mirror, and you can, because of the dotted lines, and it's highly diminished. And it's inverted or erect, we can't really say, so we will go with an extra property, that is point size. Before, for the concave mirror, we considered it to be inverted because of its converse case of being inverted, that is, the object being at focus gives an image inverted. That's the reason why we were able to say the first case of the object being at infinity to be inverted. But here we don't have any test case like that. We don't have any converse case. We can't keep the point at the focus. If we keep the point at the focus, the image won't be formed because this side is the mirror side and this side is not the mirror side. With that being said, we have completed the image formed by the mirrors.
Now that concludes the types of images formed in different mirrors, that is the concave and the convex mirrors. In the next part of this chapter light, we will be seeing reflections, multiple reflections and refraction, multiple reflections of light, as well as the Snell's law and dispersion in the next part of the chapter light. Thank you for attending, and we'll see you in the next video.